All right, guys, here we go. It's time for biomedical technology on August 25th, 2020. It's fourth period. I will upload this by 4 o'clock. If you are tuning in and you did not see a Zoom from yesterday, there was an issue with Zoom and it actually truly recording the videos. When I tried to upload it, it didn't work. I tried to upload another one that I took when you guys weren't here and it did not work again. So today, hopefully this one will work. I'm going to share my screen. This will be a longer recording for us, guys, because I have more information to go through. So clicking into Canvas, clicking into our class, that's not our class. This is our class, Biomedical Technology 1, going to the daily agenda, scrolling down to see that for today, we have the discussion post, and then we have the biomedical research PowerPoint, where we're going to discuss the 3 types of research and the 5 methods. I do not think we're going to get through all of this. I think that we will get through the 3 types of research, and then it will be your job to provide, your job to review the 5 methods tonight. You will have an assignment tomorrow on this information that we get through today. So the 3 types of research and the 5 methods, you do need to know them. It will be a graded assignment and it will lock after tomorrow night. So just keep that in mind. So this is what we're doing for today. So the discussion for today, obviously you can click in the discussion button and find it. We're going to go under modules and start the first module. So again, Zooms are here. Understanding biomedical research is our first unit. We're going to call it Unit 1 when we talk about it. As you can see, the What is Science that we did yesterday, and then the biomedical research PowerPoint, I asked you to take notes. Again, those notes are for your benefit, not mine, because I know this information, but I will help you in taking those notes later today, so stay tuned. All right, so what I'm gonna do is go through this. So biomedical research, I'm gonna talk to the guys in the class for a minute. It's kind of a lengthy one. I do need you guys paying attention. I don't mind helping and providing notes as appropriate, as long as everyone in class is paying attention and obviously people are using those notes. Okay, so biomedical research, our objectives for this unit are to discuss biomedical research. So what is it? Outline different research methods. So how do we do it? What it is, how we do it, and then the why do we do it? Analyze the benefits of biomedical research. Once you understand those 3 objectives, you have this unit. So this really isn't a bad unit. It's pretty fun. I enjoyed this one because once I understood this, everything else made sense to me. When I hear those commercials about, have you or one of your loved ones taken the drug, blah, 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 and experienced blah, 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 you may be entitled to compensation from blah, 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 blah. Okay, so that kind of started to make more sense to me once I understood this information. So again, we're going to talk about what biomedical research is, how do we do it, and then why do we do it. And we're going to break this up, guys, over the rest of the week. So we're going to have a little mini assignment tomorrow. We're going to have another little mini assignment Thursday and a mini assignment due on Friday. A quick little side note, I do have some of you who are not doing your daily discussion posts. You never know when I'm going to take those for a grade, so make sure you're staying on top of that, okay? Hint, hint, okay? All right, moving forward, what is biomedical research? Biomedical research studies the processes of life. It studies the prevention and treatment of diseases. So we can prevent and treat diseases multiple ways. We can do that with medication. We can change processes. We can change variables, okay? And to study the genetic, lifestyle, and environmental factors related to disease and health. So that's what is biomedical research. So obviously, we would study how to prevent, how to treat diseases, the processes of life, the genetic, lifestyle, and environmental factors, so that we can prolong life. We can benefit life. So if I ask you, why do we do biomedical research, and you reply to me so that we can benefit life, we can prolong life, you've answered my question. Okay, so don't overthink this. Biomedical research, yes, we study these things and we study them to better it. So moving forward, there are 3 types of research: basic, applied, and clinical. So we're going to break this down, guys. We're going to talk about what basic research is, what applied research is, and what clinical research is. Basic and applied are pretty straightforward. Clinical, there's a lot. Okay, there's a lot that goes into clinical research, but we'll get there when we get there. Let's start with basic and applied. Okay, basic research is just what it sounds like. It's basic. It's our building blocks. It's where we go in and we find out general information. Basic research is gathering information, okay? We want to understand what subject it is that we're studying. So if it's breast cancer, we're going to gather information as much as we can on breast cancer. If it's hair loss in women over 40, then we're going to gather as much information as we can in hair loss in women over 40, okay? So it's gaining knowledge, all right? It's our building blocks for other types of research. You cannot have applied research or clinical research without basic research. So a quick way to remember this: if I ask you the 3 types of research, in your mind, I want you to say BAC, basic, applied, and clinical. You cannot move from one step to the next if you haven't done basic. You can't move from basic to applied or applied to clinical without doing them in that order. Does that make sense? Okay. So moving on to applied research. Once we do our basic research where we gather information and we have more knowledge of the topic we're discussing, we can move into applied research. And applied research is where you make a specific goal. I have a specific goal in mind. I'm going to develop a new drug to treat hair loss in women over 40. I'm going to develop a new drug to treat pain in breast cancer. So, excuse me, you'll see here that the example they give is the development of a new drug, treatment, or surgical procedure. That is what you have to have in applied research. You have to either be developing a new drug, developing a new treatment, or developing a surgical procedure. And it's very specific. So in basic research, we're kind of all out here. Once we get to applied research, we're moving more towards that bullseye center of our project or center of our research. We primarily conduct applied research on animals and with non-animal methods, such as using computers, doing tissue cultures, and things like that. That's going to come full circle when we continue to move on. So don't focus too much on that because I'm going to make it make sense for you here shortly. So quick synopsis. We have basic research where we gather information. It's a big bubble and we're just piling on the information. As we get closer to the actual clinical research part of it, where we actually put it into play, we have applied research where we have a specific goal, okay? And now we're going to move on, scrolling down to the clinical portion of it, okay? So have you guys ever heard a nursing student say that she has clinicals? Or you've heard like in college where a doctor is going to clinicals? That's the actual hands-on portion, okay? So now we're at the center of our bullseye, all right? So in basic research, we gathered information. In applied research, we gathered and created a specific goal in mind. And now we're down to the really important part, the clinical research, okay? Can I do clinical research without doing basic or applied? No, they have to go in order, BAC, okay? So clinical research is done once you've done your basic, once you've done your applied, and it's where we actually test the drugs that we created. We test the drugs or treatment or surgical procedure in humans, okay? So in basic and applied research, are we testing on humans? Not traditionally, okay? It's not until we get to clinical research that we are testing on humans. So again, yes, it's building on what we already know, and there's a broad variety of activities and areas of study. We're going to do human clinical trials. Does everybody know what it means when it says human clinical trials? It means testing on humans. Okay, so we're past testing on animals. We've passed that stage. Now we're testing on humans. Psychosocial and behavioral research. So how does this new treatment affect the human as a whole? Okay, because you'll learn as we go through this, some of our methods only test a certain system or a certain part of a system. We as humans are a biological system, okay? But there are certain parts of research that don't include testing on the whole system. Does that make sense? Okay. And then, of course, disease control research. So we're going to talk about that. But we know that malaria spreads in certain environments quicker than it spreads in the United States for a multitude of reasons. Socioeconomic status, so we have the ability to control the spread, vaccinate and treat more, and then education purposes and climate as well. So those are factors we can control. So in disease control research, we really look at that. Okay? So 3 types of research. Basic, what are we doing in basic, guys? We're gathering general information. It's the building block. What's next? Applied. What are we doing in applied? We're creating a specific drug, medicine, treatment, or surgical procedure. So we have a specific goal in mind in applied. And we test on animals. Good job. Okay. And then the last one is what? Clinical. And we're testing on who? On humans, okay? Did you hear me say on human? Okay, on humans. So now we've got our 3 research methods. You'll be responsible for knowing all 3, knowing what happens in those 3, and knowing how to interpret the data. If I were to tell you that we are conducting a level of research that involves a medication to treat, testing a medication to treat balding women over 40, on animals. What level of research is this? It's applied. How did you know it was applied, Brandon? Because we're testing on animals and because we have a specific goal in mind or a specific medication we're testing. All right, so now we're moving on to research methods, okay? So very quickly, I'm going to show you what's coming. I'm going to post this online, okay? I'm going to post this online, so it's opposite to you guys. I'm going to post it. This is going to be yours. I'm taking all of the notes that are in here. Hold on, guys. I have someone at my door. Oh, thank you. All right. So I'm taking all of the notes that are in here, and I'm putting them in a nice, neat review for you. Everybody see this? It's beautiful. Okay. It's color-coded because I think colors help us learn. Okay. So I'm taking this, and I'm putting the information in here for you to have a quick reference. If you would like to make your own copy of this, I encourage you to do so. If you would like to use this to study, I encourage you to do so. But on this side, guys, we've covered those 3 research methods, BAC. And on this side, we're going to cover, excuse me, I lied to you. This is the types of research, and on this side, we're going to do methods of research. Do you need me? Okay. All right, so we have how many types of research? Are you paying attention? 3, what are they? Basic, applied. Okay, now we have 5 methods, okay? 5 methods of research. I like to teach it that way because if I say 3 types of research, your mind immediately goes to the set of 3 things we learned, okay? 3 types of research, 5 research methods, okay? So 5 research methods, all right? Stretch break, 5 research methods. So you'll see them listed here. Chemical, mechanical, mathematical, and computer go together. That's machines, okay? In vitro tests go together. We're going to talk about what that means. Non-human animal models go together. What does it mean when it says non-human animal models? So non-human animal models. What is a non-human animal? Every animal. Okay, it clicked. Yep, so break the words down, but make sure you understand, like, don't think that's a computer. Don't think it's a simulated animal. It's an animal, it's just not a human. Okay, so this is animal testing. Human studies, so who are we testing on in human studies? Humans, okay, and then epidemiological studies. And we'll get to that one last, all right? That one's not quite as fun. What? In epidemiological? You're thinking derm, which means skin, but I'm into it, and I like that you're using your medical terms. All right. Thank you, Hyatt. All right, guys, so we're moving on to chemical, mechanical, mathematical, and computer simulations. I'm going to break this down for you because that's a whole bunch of words, okay? So obviously I'm not a scientist. However, I do know a teeny little bit about what they do. So with chemical, mechanical, mathematical, and computer simulations, it's happening within a laboratory setting, but it's happening on a computer. It's happening with chemicals like substances, and it's not involving any living organism. Okay, there are no living organisms here. We are running mathematical equations. We are simulating what we think would happen on a computer. Does everybody understand that? We're putting in numbers and it's giving us a response. So first and foremost, first question, if I put something into a calculator, okay, if I put something into a calculator, does the calculator think on its own or does it just do what I tell it to? It does what I tell it to. So that is very important. With chemical, mechanical, mathematical, and computer simulations, that's the first research method, it only does what we tell it to. So that's what it means when it talks later on about some of the limitations of it. It's only ever going to do what we tell it to do. Computers, though, are super fast. The calculator is going to compute that information a lot faster than I can, okay? It's efficient. If you can enter the information, the computer can give it to you as quickly as you can enter it, okay? Computers pick up patterns, right? Excel spreadsheets can pick up patterns. Jonathan has missed 72% of test questions in Unit A or whatever. It can pick up patterns that we as humans can't always compute and pick up as quickly. All right? So these are all considered strengths. Why would we use chemical, computer, mathematical simulations? All right? So it kind of breaks it down in the slideshow about each one, like chemical, computer, et cetera, et cetera. But basically, we're talking about the pros and we're talking about the cons. So when we come over here, we're going to go through this and I'm going to list for you the pros and the cons, okay? So the pros of chemical, computer, mathematical, et cetera, is that it's fast, it's efficient, it can pick up patterns, and it reduces the number of animals that we use. Okay, I don't need an animal to put something into a computer. I don't need an animal to put something to compute data. Okay, now let's talk about the cons. Okay, so everybody take a picture or take a minute and peek at this. Why would we not want to do this? Or how are we limited if we just only ever research chemically, computer, mathematically, etc.? We will only ever be able to get the information that we compute. Right? So we talked about that calculator earlier. Calculators only do what I ask them to do. Okay? So if I only ever ask my calculator to multiply 2 times 2, it's only going to ever multiply 2 times 2. So it's not going to think for itself. There's no variable. It only does what we tell it to. Okay? That does not replace truly testing in a laboratory on a living organism. Okay? So where it says that computers do not generate data, they only process data, that's that calculator thing. A calculator is not going to know that the next step in the equation is to divide by 2. All right? It's only going to do what you tell it to. And then, of course, computer software and equipment are very expensive. All right? Any questions about chemical, computer, mathematical, etc.? Just think computer machinery. How is machinery beneficial? Okay, it's fast, it's efficient, okay, and how it's not testing on animals. And then how is it not a good thing? So it's not a good thing because it's pricey and it's only ever going to give you what you want it to. Okay, so moving on to in vitro. Has anybody ever heard of in vitro? All right, so in vitro means in glass. So have you guys ever used a culture plate in a microscope? It looks like this, and the culture plate has, you might scrape your tongue and put it in the culture plate. We talked about it in Health Team Relations, a lot of you, where they scrape their teeth and then they put it into the culture plate. We talked about who created it. Is that ringing a bell, Jackson? Okay. Yeah. So, huh? I can't remember either. But I think it's wonderful if you find out. He asked me what was the guy's name, and I said I couldn't remember. Okay, so in vitro is an artificial environment. So in vitro, again, is this small glass plate. Okay, and this is how I remind you guys what in vitro is. It's a small glass plate, and we control the environment in that glass plate. I might take a sample of skin cells, okay, and I put them in this glass plate, and I can test on these skin cells to see what my new medication or my new drug does to these skin cells, okay? But there are some cons to using this. So we're going to talk about the positives first, and then we'll talk about the negatives, okay? So some of the strengths of in vitro studies. We can study the effects of our medication in this environment in complete isolation, okay? We control everything about what's going on in this culture plate. The temperature, the humidity, the O2, which is your oxygen, we control it all. So there's not a whole lot of variables happening to this culture. And a culture just means a sample, okay? It's less expensive and takes less time than testing on the whole body, okay? So instead of testing on my whole body what a new lotion does, I'm just gonna test on a sample in my in vitro studies, okay? And because we're controlling the environment, our results are pretty spot on because there's not a lot of variables, right? If I'm controlling the temperature, I'm controlling the humidity, I'm controlling the oxygen, I'm controlling every detail of this culture, which is our sample, then there's no variables. So the results are pretty accurate, okay? And of course, it's critical because skin is a living organism to a degree, to a level of skin, obviously. And so it's really critical in events where like we're studying a virus and the virus only grows in a living environment because we can simulate that in our culture plate. Does that make sense? Okay. So those are the strengths of in vitro, all right? We're gonna move on to the limitations, okay? We're gonna move on to the limitations, all right? So in vitro studies are limited because, of course, if I take a skin sample, okay, and I test on my skin sample, do we know what that lotion is gonna do to our cardiac system? Why not, Brandon? He said no. Why not? Because I'm only doing it to the skin. So we are limited in knowing truly what that medication or what that surgical procedure or what that new treatment would do to the overall system. Again, we as humans are a biological system. Okay, we're limited when we do in vitro. Also, the cells that we are working with within our culture are, again, limited to just what we control. So it's not like if we're testing a lotion on the skin cells that we took a sample of in our culture plate, what happens to the nervous system? Are we going to take away sensitivity and feeling with our lotion? We don't know because there's no systems connected, okay? It's difficult to maintain differentiated cells in a culture. So if we have skin cells and we have kidney cells, it's really hard to keep them from mixing. And along with that, which we've already kind of hit this, guys, the cultures cannot tell us how a substance affects a complex system. Would you guys consider humans complex systems? Yes, why? Absolutely. So we have all these body systems working together at one time to maintain homeostasis. So 100% humans are a complex system. Okay, so far, guys, we have gone over the 3 types of research: basic, applied, and clinical. We have gone over 2 of our 5 research methods, and I want to check our time because I want to make sure we're not getting too long here. We're pretty long. Okay, so what I'm going to do, guys, is here I'm going to stop. I'm going to have everybody take notes on this information because tomorrow, your first assignment will be due tomorrow on this information that I've gone over. So you need to know those 3 research topics, front, back, and sideways, and you need to know the 2 research methods that we covered, okay? So you need to know basic, applied, and clinical research types, and then you need to know the methods, the chemical, computer, mathematical simulations, and in vitro, okay? Because that's what your assignment will be on tomorrow, and it is graded. Okay, so come back tomorrow to the Zoom and be ready to go over the last 3 research methods. Okay, does anybody have any questions, comments, or concerns? Thanks, guys.